Welcome to PharmaSource.
Welcome to the PharmaSource podcast, where we interview business leaders in life sciences about the issues which are shaping pharma and biotech. AI and data science are a massive opportunity for life sciences, with data-driven decision-making making an impact across all areas of business. So I'm pleased to be joined today by Johannes Galatsanos, Senior Director at Novartis, and recently a Sloan Fellow at MIT. Johannes has maths and computer science background and is currently studying and researching AI and business at the University of Oxford and then MIT. Johannes, welcome.
Hi, Luke. Thanks for having me.
So let's start off then talking about Novartis, because until recently you were involved there in a huge transformation of the core systems and designing for the new ERP system, which will be rolled out globally. It's a huge undertaking. So could you give us an overview of this project, please, and how you approached the data-centric design?
Sure. This project about replacing our ERP systems and our core systems related to that had a long history as part of, let's say, having legacy ERP systems. I think as most companies who have used that platform needed to at some point do a technical upgrade to a newer version, especially also a bit more cloud-based. And this was, let's say, long time in the making and long time trying to sell this technical upgrade. So it has quite a long history behind it. But then I think it started about 3 years ago, this incarnation of that project. And a big driver behind it was, of course, one, the, let's say, technical upgrade, which is necessary, but secondly, also consolidating a few dozen of ERP systems, which were local, into one platform and unifying also our processes and data. And then the third part, which led a bit to that project, was that we saw and management also recognized more and more the value of data. So in 2018, Novartis new CEO Vas pledged that we would become or go big on data and digital. And we experimented also a lot with AI and had some very cool use cases as well there. But as anybody who is walking in that field knows, good AI needs good data. So to do also analytics, to standardize our processes, but also just to optimize normal workflows, we needed to have or pay a lot of focus on good data.
And so for you then, ERP, that's the foundation, would you say, for AI and data science, certainly within manufacturing in pharma?
Yes, so that's a good point to clarify. So the transformation looked across multiple functions. So it was around, I think, most fields except R&D, if you want. So it was manufacturing, supply chain quality, finance, procurement, commercial. And it has, let's say, some of the very foundational data in the way how we build our ERP systems legacy-wise. It has a lot of master data, what we call, so key foundational data that is used by most of the company in all kinds of processes, from R&D till commercialization. And yes, so this data is core if you want to run most use cases of AI anywhere in a corporate environment. Yeah, and this is why we saw a lot of value in improving this core data across all these systems.
Data quality must have been key for this transition. So how did you define what good data looks like?
We needed to actually think about a good approach, how to explain what is good data and what are we actually trying to achieve in this case, which was also important that we can later justify ourselves if this project was or program was successful and what did we actually deliver in value. I think there was a few steps in between. The first was to first classify what data we're talking about. So I mentioned already a few areas. And we needed to clarify what are the exact data assets we're talking about. And this isn't very easy because Novartis being that big, obviously the data is quite distributed across different applications. And it's also quite difficult to distinguish what you're talking about. I can give an easy example, which I think anybody in the pharma industry would know, is the customer. The customer, when we talk about a customer in the context of ERP, it is normally somebody we have a financial connection to. So there is some sort of invoicing happening or some ERP process, which means that This could be, let's say, it could be a warehouse, it could be a distributor, it could be an organization or a hospital that we actually ship products to, right? The medicinal products. But from another view on the customer would be actually our patient, right? Who actually receives the medicinal product. And then a third view on it would be the healthcare professional, which our commercial team is actually talking to, the one who prescribes the drugs. But normally, in most cases, we don't sell directly to a doctor and also not to a patient because we don't do over-the-counter business. So in this case, the customer is three completely different things, but we still need to somehow define the terminology, right? What is the customer and how do we unify this? Because in some cases, for example, in the US, yes, you can sell to a doctor, right? And this could be the same person or even a supplier. A doctor could supply, participate in a study. So this needed a lot of discussion about terminology, right? What are you even talking about and what are the boundaries of each of the data assets?
Where did you land on that? Are healthcare professionals, is the patient within scope for the implementation?
The patient not, but the healthcare professional, yes, because there could be a financial transaction, first of all. So it could be either or supply, right, of product, because a healthcare professional could be a supplier to a study, as mentioned, which means there needs to be also some sort of ERP transaction, or we could supply something to the doctor, right? And then thirdly, which is very interesting or key for us, is to have this intelligence of what is a customer, or let's say of the full view of a particular healthcare professional, right? So we can customize also to the HCP the services that we provide. So if a field force goes to a particular doctor, they need to know maybe this doctor participated in a study, or actually we supply them particularly with medicine. So this is kind of a customer 360 view. And for that reason, yes, there needs to be unification of customers, of all the different types of customers we have, because of that middle ground of let's say intersection of different types of customers who are the same person, let's say Dr. Smith, right? And for that reason, yes, we went for unification. The modern ERP systems, actually, they talk about, for example, a business partner, right? They don't even talk about customer in this context. So they say a business partner can be supplier or customer or different types of customer, right? In our case. So that's already out of the box there. The difficult part is, how do you take those different processes? One is in commercial, one is in finance, one is in procurement, and actually connect them to each other, so that these different departments don't duplicate again the same customer based on their processes, right? And ordering, or a field force, right, goes to the actual physical place, the hospital, right, and talks to the doctor. When they put the data in, they need to know this is connected to ERP. So this is a big challenge. It took a lot of time and design effort to do it. And yeah, it's still experimental, right? So we haven't rolled it out yet, but this is the idea.
And while you're talking to me, Johannes, I can see behind you this beautiful panorama of the River Rhine, which looks fantastic.
Yes.
You mentioned
Thank
that
you.
the river itself has influenced your thinking. How has it done that?
Yes, actually a very good point. Yes, so for our podcast listeners, I guess that you wouldn't see it, but if
Yeah.
you see the picture around, I'm actually sitting here and have the privilege to sit and look at the River Rhine, especially when we were doing the design and we were all stuck to our houses, and had a lot of time to contemplate about how to take some ideas on data design. So the Rhine, actually, if you sit here in the summer, then you would see a ton of swimmers in the back. So lots of people love swimming here. And it's one of the favorite pastimes in Basel. Is if when it's a hot weather, you just jump in and swim under the bridges. It's beautiful. And when I looked into that, I thought this is like an ancient tradition in Basel when I first moved to Basel. But I realized this is actually quite recent. So it's only the past few decades that you can actually swim in the Rhine. Before that, so if you were here in the 60s, you could barely, even any fish could survive in the Rhine because of the post-World War production increase here around this area. So it was a very polluted river from all kinds of sources. That's a very interesting case of environmental mega projects that led to a very good result, which is not that well known, actually. So in the 70s, all the countries around the River Rhine started coming together and having a unified view on how to clean the river. So they thought about a few things. One, they need to put regulation in place to actually prevent pollution from the different sources. So it could be industry that is around the river. It could be also agriculture, and anything around mining and so on that could actually pollute the river. But also policies of the cities that are at the river, right? So how can you actually deal with this water? And then the second part of it was a bit fishing, or cleaning actively the river. So going with boats and nets and fishing out all the stuff that was in there. And third, then obviously policing. So they were looking at what is the quality of the river, or the data quality, or let's say water quality, sorry, of the river, having accountability towards the participants here, so towards agriculture or the industries who were polluting, and actually holding them accountable for helping clean it up. And this was a mega project that lasted decades, but with very consistent policy, right, of cleaning it up. All the member states here were participating actively. And yeah, today you can actually swim amazingly here and have a great time at the Rhine. And now this kind of inspired a little bit an approach. So how to actually deal with data. And today we talk a lot about, for example, the data lakes, right, that you see everywhere, data warehouses. And in my experience, the data is not steady in a lake, right, where the lake gets actually polluted over time and becomes a data swamp, right? Because the data flows, right? We have also this point of this water that already exists, data flow. And I like to think a bit more about a data river. So the data flows from different sources. Yeah, you could think about cities on the Rhine that are giving, these are processes, let's say in finance or in operations, who are actually giving data on producing data into the river. The data flows with time, right, downstream. And when you create important data, like say a supplier, later on you might make an invoice about it, right? Later on you will use it downstream for other processes. And what we have done is then we take the data from that river, right? And we put it in a data lake. And this data lake we can use then for analytics, for data science and AI, right? Because it's a more controlled environment than the whole river. So most of, let's say, the chief data officers and most of the data management has focused on building this modern data stack, which is the data lake. But what we haven't thought about and what we haven't done consistently is think about the river that's actually supplying all this data. So we were trying to somehow clean this data swamp, but there's still trash coming in every day through the river. So the approach we took was, all right, let's clean actually the river, not just the lake, right, that we have. And there we learned from those policies. So there's three things, I think, that just to make it super easy and explain it to everybody, there's three things you're doing to clean this river. So one, you need to think about the data creation. So once you're creating the data in the first place, this is the source of if you want pollution, right, of the water. You need to make sure that this is clean. So if you already produce bad quality water, there's no point afterwards cleaning it because the river is polluted. So start at the source, right? When you start at the source, how do you do that? You need to bring policies in place, right? Like also the countries here did, to say, here you have pollution policies. We also have monitoring. So this is the second part, is monitoring. How do I see who's polluting? And can I hold them accountable, which is the third part, right? Ownership and accountability. So I need to measure the data quality at the source. I need to make sure that they have the right policies. And then I need to also hold people accountable if they're polluting these waters. And if I can consistently apply this across the enterprise, right, these rules, then I can, improve the data quality over time and clean up my river over time. It's a long process. And we were in a luxurious position that we could replace, let's say, a whole country, if you want, right, in the scale of the Rhine River. Yeah, so we were replacing this ERP core system. So a huge part of the cities, if you want, and the factories at the river at the same time with this ERP program, which means we could immediately apply all of these policies, right, of creating good data. So we could prevent a ton of the future pollution. There's still some pollution in the river, obviously, from the legacy. And as we're rolling out, there's still pollution coming in, but at least big parts of it are clean.
So presumably that would involve quite a lot of internal training, would it, around how to sort of train people on the new processes and make sure that they're abiding by the rules? How have you found that as part of the rollout?
Yes. So I think that goes to the topic of culture, right? There's many parts. So there's many parts around the culture that we have to think about. So one is even to create this awareness, right? So how that you're actually polluting these waters, yeah? And often the polluter, this is a bit also the same problem in environmental sciences, right? But the one who pollutes is not the one often who actually has to live with the pollution downstream, right? So you throw some trash away, you might not see it again, right? And in the same way, a bit the people who are creating the data producers are not necessarily the data consumers later. Yeah. So you produce something, you just, you're in the field force, you need to quickly put something together because that's the process. And the doctor, you don't need to put now the exact address and name and everything correctly. And maybe there's a duplicate, yeah. But I know who the doctor is, right? Why do I need to put correct data in now? And I will go and visit him again or her. But people downstream will have a problem identifying, wait, you now created 5 times Dr. Smith. Yeah, is this the same person or not? Yeah. This is, let's say, making first awareness, right? You're polluting, but this data is very valuable that you're creating. So everyone creates very valuable data. You need to understand the value of it. And you need to show also use cases. Yeah. So what are the actual use cases where this data can be useful down the line, right? Maybe for compliance reason, for efficiency, for an AI application, maybe the use case which is important for you later on, right? So we worked also on AI applications that help you guide you through the field force and help you, for example, coordinate routes and so on, and optimize, how long do you have to talk to the next HCP? And this uses the data that you have input as a field force. So, it's in your own interest to actually be good at it. So as you say, training, letting people interact with those such use cases of analytics or AI, ideally, but also then furthermore, or let's say in a bigger context, becoming a good data citizen, right? This is, let's say, how we talk about it, right? You are responsible for creating your data, you're responsible for maintaining it, you're responsible to know what kind of impact this data has, right? And also how do you steward this data, right? Because this data, especially if this is sensitive data, right, or data in a GXP environment that is regulated, you need to be even more responsible and know all the data privacy elements to it, right, and the ethical aspect behind it. What most people do today, especially if they have more technical background, is they would throw what we call data quality tools. So they would throw expensive tools with a lot of rules in there who detect issues. And then you have to manually go back and correct them, right? And this is a problem because this is expensive. This is, if you think about the river, you throw in some trash into the river, right? And then you send in little ships with nets to fish it out. But I mean, you need a ship and you need people to go in and fish it out. This is expensive, right? And this is much more inefficient than just preventing the pollution in the first place. Yeah, just putting a trash bin somewhere they can put it in. So this part of monitoring and correcting data, right, is expensive. And then the part of production is kind of also expensive, but you do it once and then it's done, right? The cleansing you have to do is an operational cost. Now, if you think about what AI can do, or how you could also use AI to become better at this. So one, you have there is GPT, or not necessarily GPT, but these foundation models. They were created, especially language models were created also to be good at translating languages, right? So from French to German or so. But if the big problem with translation is that the words, let's say if you take a word, especially in French and German, yeah, if you would say, you cannot take a one-to-one translation, right? You need the whole sentence and maybe put the verb at the end and so on, yeah? So German is a difficult language and so is French, yeah?
I think so.
And
yeah,
yeah, exactly. So the way how these translation models were built is they're very good at detecting these kinds of patterns, mapping things, right? That's the whole purpose behind them. And now what you can do for data is the same principle applies actually for connecting different data models to each other, right? So when you're creating the product data model for Novartis and you want to connect it to another data product model of a supplier of ours and vice versa, you can use actually these models to find this mapping and actually help you with the kind of mapping and modeling. So this used to be a manual walk. It's now more and more an automated walk. There's already some tools on the market that do that, but with those foundation models, I think it would be even much easier to do it. What you can also do is with the data quality, so the monitoring, right? The monitoring of the water or data quality, if you want. They are using this, can also accelerate it a lot, right? It can really tell you also create new rules of what data needs to be in sync with what other data and so on. And it can help you detect much more of this data quality issues and also instruct automatically, maybe with a chatbot, right? But instruct the people who are responsible for the data, right? So your little assistant pops up and says, hey, Johannes, yesterday you put in this doctor name. You know what? Actually, I think it's a duplicate because I found him in the ERP system. Can you please update, click on OK and I will do it for you. Yeah? So this kind of capabilities, they come more and more in play. We didn't go down that route yet, at least, right, with the design to use these kinds of automations. But more and more, I think that as this becomes better, you will have better capabilities of cleansing your core data as well, right? So cleaning up the river.
And do you think there's scope for more cross-industry collaboration across pharma in terms of data exchanges? So to take your River Rhine analogy, the different countries which are pushing into the river. I mean, what's your experience been of that and harmonizing standards?
Yeah, that's a very good point. So the design principles, or one of the main design principles we had, is when we creating new data objects, or when defining these new data assets, is to use standards, so standardized data formats. Yeah. Now, let's say easy example, currencies, right? A currency, you have yen, USD, and so on with the symbols and the 3 letters. So this is like, it's a normal standard you can take. Most systems have that out of the box, easy. Countries, yeah. When you talk about countries, this is not so straightforward because you could say, let's take, for example, an ISO code. However, we have Kurdistan, right? Kurdistan is not an ISO country, but it is actually has a health authority. So we would need to supply to it. And this in particular means, this ISO standard doesn't help you necessarily, right? Or can help you to an extent, but needs some modification. Now, what we always do is go for an external standard. So this is always the case because with external standards, we can cooperate with other companies, suppliers, hospitals, right, and regulatory authorities who speak the same language. Now, in pharma, regulatory authorities and ISO norms have also helped us, like ICH norms or IDMP, ISO IDMP, which help us a bit in speaking the same language, or for example, about products. Yeah, what is a medicinal product? What is it composed of? This is itself a huge science, right? It took many, many years to even come to a consensus of how to describe a medicinal product, because the science expands. Right now we have radioligand therapy, we have cell and gene therapies, all kinds of medical devices, combination products. So the definition you might have had 10 or 20, 30 years ago is not applicable anymore, right? It needs to be continuously updated. But you have a standard, right? And this standard, use it as much as you can so you can talk to others. This also exists in the clinical space, much more actually, which is great. So that in the R&D space, we have much more applications there. Because it's a much, let's say, longer history of standardization and need between universities, right, research institutes and pharmaceutical companies and governments. Yeah. So there was a lot more need to standardize things. But now more and more this needs to happen in all other areas as well. So this can help us to communicate better between each other, right, in supply, demand, and stockout prevention, right, and all other use cases. But there's another interesting use case now, which is coming up, which is AI related, right? So when we talk about how do we actually train models, for example, right? So when we have big foundation models, yeah, like GPT or other large language models, the way how we would interact in the future more and more, this is my prediction of seeing the evolution in that field, is with a form of distributed learning or federated learning. So federated learning means that we don't want to share, or we're not allowed to often to share the data with other organizations or companies. For example, could be anyways protected data that nobody was supposed to have, or that we cannot share, legally speaking. But it could also be data that gives us a competitive advantage, right? Or I don't know, supply, you don't want to give all the list of your suppliers and all the list of your customers. Yeah. So intellectual property data, right? However, if you want to, let's say, train your foundation model to work on optimize, for example, your supply demand planning, right? Or optimize or help you with research, or help you with preventing stockouts or something like that. You don't necessarily want to give all the data, but you can train the data locally without giving away your data. So this is what we call federated learning. And this principle is actually quite simple. So it's doing the same thing as learning on one big data set, but it actually just gives you, so let's say it works daily. It would train the model in, let's say, 20 times if you have 20 companies participating locally. At the end of the day, on your own data, so your own data never leaves the premises. At the end of the day, you give back your model, right, your updated model to the federation, to the center, not the data, just the model, so the weights of the model. And at the end of the day, you see who wins, who had the best model, right? So you take that model and then you send it back the next day. So the data never leaves your premises, just a model update. And I think this would be the future of cooperating and training AI in this federated model, because without giving access or without sharing all our data with everyone, right? That we don't want to or cannot share. So this is, I think, another big argument for standardizing data, finding common data models between pharma companies, suppliers, governments, research institutions, so that we can actually use AI in that context as well.
Well, let's talk more about AI then. We've talked obviously a lot about the importance of data quality and standardization to make sure you've got the foundations right. But if you were to look at the opportunities, once you've got the data foundation right, which areas do you see AI making the most impact within areas like manufacturing, sourcing, supply chain?
So, I mean, the use cases, I think we're just scratching on the surface, right? On use cases, there's tons of use cases around. And so after ChatGPT especially was released last year, the exposure to AI by such a wide variety of people has been insanely big. And this sparks more and more, let's say, use cases every day, right? If you ask around, then people will come up with a new use case every day. And this is, I would say, more on the large language models. But then there's also, I think, the boring AI, right? So the boring AI, the old school AI, if you want, which is, it could be a support vector machine, right? But it could also be this, linear regression, basically, right? So what is most kind of AI actually today, if you want data science and an extension of data science? And in these use cases, which is more a numerical optimization, you would have all kinds of things in financial automation, right? Financial processes, procurement processes, process optimization, digital twins you could create, right? You can improve in manufacturing, safety, quality, compliance, supply demand planning, right? Like say predictions, yeah. So any kind of prediction in general, which includes also production planning, right? Production execution. You can also optimize things in supply chain like track and trace. In procurement, you could think about deduplication, or let's say finding opportunities in reducing purchasing costs. So it could be, let's say, finding around your whole organization duplication of suppliers and raw materials. And then you can say, maybe I'm buying 10 times, right? This raw material from different aspects and different suppliers, but actually it's the same raw material. Maybe I can negotiate a better price, right? Also prediction of shortages, stockouts and so on. Anywhere where you have some sort of prediction, right? This is basically where you could use it. And this is now only the operation space, right? So there's obviously also the whole R&D space, which is a whole different animal. And maybe I should also clarify that I'm, focused more on the operation space, or more, let's say, post-commercial. And R&D is a very interesting space, but also has very different context and very different issues to an extent. But also very cool use cases, right? Like Stanford, the Biomed LM, this was built a GPT for from PubMed, the publications on medical papers, anything around that research, target finding, and so on. So there's a lot of areas that can also help in R&D, but I think this is more very interesting cases in operations as well.
Yeah, absolutely. So focusing on that for a bit, use cases for AI in terms of making operational improvements. There's two questions I've got for you on that. One is, do you see that happening within the ERP itself or some other software which you would run with it? In terms of use cases, how would you quantify some of the business value of some of these initiatives?
Yeah, let me start with the first one. I mean, we talked already about large language models or foundation models. Those are very interesting because they are kind of the Swiss Army knife, right, of AI. So it can do a ton of things, right? It's not an expert in anything, but it can do a ton of things. And it's a more generic model that can be used in a lot of ways. Most cases, let's say in the corporate environment, though, you might find a specialized tool, at least at this stage, more energy cost efficient, right? Training efficient, and also maybe giving you better predictions. Yeah. So anything, linear regression, the boring AI we talked about before. If you go to Hugging GPT, which is kind of the repository of all the big all the big AI repositories there, you can find the right tool for you, right? Even with Hugging GPT can tell you what is actually a good tool that exists there that can help you with your current problem. And it's not necessarily ChatGPT, right? I mean, most cases it wouldn't. Let's say you want to now go a bit and use those LLMs. There still are some unsolved issues. So there are first attempts of getting LLMs ready for an enterprise environment. So actually Microsoft is pushing ahead with the Azure OpenAI ChatGPT plugin. So you can even today actually go for it and plug in GPT to your internal, let's say, knowledge base, for example. So you can do a great sort of knowledge management, right? So if you have a question, if you ever use search today in your enterprise, sometimes you're better if you look in Google, right, to find something out about your company than actually the internal search. Yeah. But this might reverse. Yeah. So if your GPT then has access to your internal knowledge base, it can quickly answer you a question you have. Yeah. They gave him an example in that video. When is the office move happening? Right. So you could say, oh yeah, office move is happening in 6 months. So now you don't have access to all of the information now, but here's just some rough information. It can help with communication a lot, right? So because communication, which is something that falls apart, in big organizations, always the first thing to kind of fall apart. Yeah. But help you a lot with personalized communication. So what's the information that is important for your job? And do you have a question that needs to be answered that you don't need to write an email to somebody in another division who you don't even know, but, just ask your internal GPT about it and it will spit you out. Yes, we are launching that product in Q2 2024 or something, right? So it can tell you a lot of information you would otherwise need to send an email for. So this is really cool. This communication knowledge base use case. However, there's a little bit of still unsolved issues to an extent. I mean, first is the cost, speed, and infrastructure restrictions to this, which, if you used it now, if you have 100,000 people using it daily and you make X requests, it's going to, add up in costs quite significantly of all these queries. Yeah, so maybe there's a better way to answer some of these queries. Second, and I think more important actually than this is anything around privacy, security of the data that you have, right? Is this, let's say, contained enough not to leak, right, outside? Is it, there could also be, let's say, prompts, if you do the proper prompt engineering, you could, you don't even need access to the GPT of your company. You could actually take this federated learning GPT, right, and ask it and maybe infer things about, let's say, Novartis in this case, right? which you actually trained that algorithm to know, but you shouldn't, right? So the model should know about it, but it's, was trained by it, so it could spit out some of this information. So this needs to be properly contained, right? And then general AI safety, right? So what is the unexpected behavior of that GPT that you would have, right? That chatbot. It could be something, maybe there are ethical concerns with it. It could create some copyright infringement, right? You don't know what it was trained on. So maybe the image you're creating for your marketing campaign, later on you have a copyright case for in your hands because somebody might claim a copyright for it. Or hallucinations, right? So let's say I ask it, especially if I'm production, let's say in a GXP area, which is regulated, and I ask, well, GPT, tell me, what is, let's say, your prediction for my ordering for the next quarter, right? How much should I order, right, for my country organization? And maybe it comes up with a hallucination there, or gives me a wrong fact, and that can then lead to a decision which has other impact down the line. And this is not good, right? And it could spread misinformation accidentally. Yeah? So this is not something that you would like to have in your core processes, but more something that supports you.
How would you approach process mining? So once you've got a history of lots of operational data, what could you use that?
Yeah, so process mining is an interesting one. Optimizing your processes and having a better view into metrics, right? So this is, I would say, more in the analytics space. And process mining is a very good way to hold you accountable for the decisions that you took. That goes a bit into decision making, right? So when you take a decision to implement a new tool or update a process, or let's say bring an update to your system tool, process mining, which is, for anybody who doesn't know process mining, maybe we should introduce that quickly, but that is actually looking at the audit trails of the individual clicks, if you want, or actions in a system, and then reconstructs what happened in that system as a process. Yeah, it could tell you that you click that, for example, you started a change request, and then somebody approved it, and then you did analysis, and then somebody else approved it, and then maybe somebody canceled the approval and went back, so you had a little bit loop. And maybe the process got stuck somewhere, right, in with someone in a country, and then it came back again after a month. So you can see patterns like this over time, and you can optimize processes. And once you see those patterns, you can say, well, let's do some investment. I invest, X dollars to improve the process here. After I go live or I do a training or something, right, to improve the process, it helps me as a process owner or system owner accountable that in a year's time, I saved that much, I brought that much efficiency with this change.
So you could look at an entire end-to-end supply chain, could you potentially,
yes.
and start like identifying where there are breakdowns in the supply chain.
Correct. Yeah. So that's actually a great example, Luke. So you can look end-to-end processes, and this looks at the end-to-end supply chain and sees where you have inefficiencies, where you maybe have feedback loops, right? Something gets stuck. It can even find or be proactive on something that, okay, look, if we continue like this, we might have a stock out somewhere. So let's, or production delay or something like that. So let's, go back and fix this issue. So this is a very interesting technology, and very importantly, it helps you to keep you honest, right? So you take a decision. It's not like a fancy PowerPoint, I did this and we have 5% improvement, but you see it really on the audit trail across all the globe. Did I actually improve by X amount or not? Yeah. And if you were very radical, right? So anybody who's promising savings, every project promises savings, right? You can actually quantify this now. Yeah. So process mining is great. And the idea also in Lean Digital Core was to use it across. I mean, ERP, this process mining is already out of the box, kind of, right? Not fully, but it's fully integrated to ERP. And it's a kind of a no-brainer to use it to see how the processes have been improved after go live.
It's been a fascinating conversation. I hope it goes well for you in Cambridge. I think MIT's gain is very much Pharma's loss.
Yes, I'll be working on business AI, the intersection of it. MIT has also some great centers there with the Media Lab. So yeah, I'm quite excited.
Yeah, I'd be fascinated in hearing more about it. So once you're settled in there, please come back.
You've been listening to the PharmaSource podcast.